Hey everybody, and welcome to another Math Minute on sequences and series. We're looking at Unit 6 for this quick video. I just want to talk about absolute convergence a little bit. This is one that a lot of students have trouble struggling with the logic and the procedure behind proving absolute or conditional convergence. So with absolute convergence, if a series is absolutely convergent, then that means that the absolute value of the series converges. And if that's true, that means that the series also converges. This is a theorem we're given that implies if it's absolutely convergent, it is also convergent. This is really helpful when it comes to trying to prove convergence, absolute convergence, or conditional convergence. If a series is not absolutely convergent, then that means the absolute value of the series diverges. And the series itself may be conditionally convergent or divergent, but it's definitely not absolutely convergent. So what does this mean for a strategy for attacking these problems? Well, I'm going to start out always with taking the absolute value of the series and seeing if that converges. So take the absolute value and then look at our list of all the tests from Unit 5 and 6 that we've gone over and see which one you can use to prove convergence. If you get that the absolute value of the series is convergent, then the series is absolutely convergent and you are done because you know that the original series will also converge from that theorem. If it diverges, well, then we have to keep going to step 2 down below here. So once I've proven that it's not absolutely convergent in the second case, then I have to go back to the original series before I took the absolute value and do a convergence test on that one. A lot of times it will end up being the alternating series test, but it doesn't have to be limited to that. Just be careful if you're dealing with a series with negative terms, you cannot use the integral test or either comparison test. All of those require all the terms to be positive. So once I test the original series, if it converges, then that means that the series was conditionally convergent because we already proved it was not absolutely convergent. If this series diverges, then the answer is divergent. Not absolutely, not conditionally convergent. It is just divergent. And once you've done that, you are done. So these could be a little long if it turns out they're not absolutely convergent, but you can save yourself a lot of time by starting with the absolute value and testing that out first. Good luck on these problems.